Welcome to my video on percentages. In this video we're going to learn quite a few skills, first of which being what a percentage is, and from there we're going to learn how to find any percentage of any number, which is the most useful skill, and from there calculate discounts, calculate a reverse percentage, calculate something called compound interest, calculate depreciation, change any division into a percentage, and finally look at percentage increase and decrease. For most of this we'll just need one method, and that is finding any percentage of any number, and I'll show you a fast way to do that in just a few seconds using a skill you've already learned instead of a long and convoluted way, and you'll get to a point where you'll be able to do these in your head. First of all, let's talk about what the word percent means. The word actually comes from a bit of a mix of Latin and French. Cent, which you may know in French, is 100, pronounced cent, which comes from the Latin centum, which means 100. And there are some other words in English that follow this, such as centimetre, century, centurion, which is from the original Roman army. So cent means 100, and they all mean 100 things. So 100 centimetres in a metre, 100 years in a century, 100 soldiers, 100 centurions in an army division. And another one is the word cent, as in dollars and cents. How many cents are there in a dollar or a euro? 100, because cent means 100. So percent means out of 100. So that's all that a percentage is. It's just a measure out of 100. So for example, if you were walking down your local high street and you asked 100 people, like they do in Family Fortunes or Pointless, do you like maths? Then let's say you've got a whopping 40 people out of 100 that say yes, they like maths, then that would be just 40%, because it's just another way of saying out of 100. So it's just like a fancy way of saying out of 100%, or percent, 40%. But in English we mangle that to percent, so 40% just means 40 out of 100. Now this is really one of the first abstract concepts that we come up against in maths, because usually we'll use percentages to measure things out of 100 that weren't out of 100 in the first place. So let's say, for example, the next day you were walking down the high street and again you asked people, do you like maths? But you just couldn't be bothered to ask 100 people, so you only asked 50. So you asked 50, do you like maths? And this time, let's say 25 said yes. So 25 out of 50. Now when you report back to your boss, you don't want to tell him that you only asked 50, you want to tell him out of 100. So you'd say to yourself, okay, I need to make this out of 100. So how will I change 25 out of 50 to be out of 100? So just pause the video and think of the answer. So to do that, then we need to times 50 by 2, because that'll make it 100. And we'll do the same to 25, which makes 50. So 50 out of 100, or 50%, is what you could say to your boss, and it gives the illusion that you've asked 100 people when you haven't. And this is, like I say, the first abstract concept, because we're measuring something out of 100 that wasn't out of 100 in the first place. And most things in life are like this. They will measure things as if they were out of 100. So think of some examples of yourself, like when you look at a video game review, it'll say 87%. Well, it wasn't really out of 100 in the first place, it's just a made up figure that's nice and round for us to work with. If you look at a shampoo advert on telly, they'll say something like 87% of women love this product, or something like that. But you look in the small print, they won't have asked 100 women, they'll have asked something like 202. And then they'll say that's 176 out of 202, or some number similar to that, will like the product. And you might think, well, why don't they just say that? Well, because if you say that, first of all, it takes 30 seconds to say it, and second, it takes a little bit of thought. So if you convert it into a percentage and say, instead, 87%, gives the illusion that they've asked 100 people and 87 said yes, even though that's not the case. And we see the same things with company profits. They'll report they've got 10% profit this year. They haven't made £100 and then £10 more. It's usually 10% more than some figure that's not 100. So most of the time, we don't actually deal with 100. But we want to make it out of this useful number that's a nice round number and easy for us to deal with. So the next part of my lesson is going to be about where this happens in a comedy. So there's a film called Spinal Tap, and there's a scene where there's a musician talking about his amplifier, and the amplifiers are better than anyone else's because they go up to 11. So I'm going to play the clip on here, and then we'll talk about it afterwards. But while you're watching the clip, the documentary maker asks the question. So I want you to listen to that question and think about, why does he ask it?
Where can you go from there? Where?
I don't know.
Nowhere, exactly. What we do is, if we need that extra push over the cliff, you know what we do?
Put it up to 11.
11, exactly. One louder.
Why don't you just make 10 louder and make 10 be the top number and make that a little louder?
These go to 11.
So the question that I found interesting is what the documentary maker asks, which comes intuitively to him, is that, well, why not make 10 the top number and make that a little louder? So this is the whole joke, that it feels like 11 is louder than 10, but the documentary maker, the interviewer, automatically says, well, why not make 10 the top number? But why 10? I mean, why choose 10? I mean, what difference does it make what number it is really? But what intuitively comes to him is that 10 should be the top number. And that's because we've got that sense of out of 10, a score out of 10, 7 out of 10. We tend to rate things out of 10. It's a natural maximum for us. And it's the same with 100. We have the same thing, that kind of feeling of out of 100 as a percentage. So if we do an exam, it's not out of 100, we'll report it as if it was. We'll say, instead of saying I got 64 out of 72, I'll say I got 88% or whatever it was. And it gives us a figure that we can all compare to. So, you know, what did you get? 88%, what did you get? 72%, even though the original test wasn't out of that. Same for 10. The interviewer says, why not make 10 the top number? Because that feels like the top. 11 seems like a strange choice. And of course the whole joke is that 11 is no louder than 10, because it's either completely off or it's completely on. It doesn't actually matter what number it is. So he says, well, why not make 10 louder? And of course he doesn't get it at all, but I won't explain the joke any further to you. So this idea of having a maximum is called normalisation. And it's a horrible word, I'm afraid, but it's a very useful word because it happens a lot in maths. We want to normalise things, i.e. have a kind of maximum that we can refer to. And if we think about 100%, what number does 100% equal? So just pause it and think for a sec. What number does 100% equal? Well, 100% means 100 out of 100. 100 divided by 100. Well, that's an equal to 1 division. Equal to 1 division. So that means that 100% is 1 as a number. So when we're normalising, or when we're doing this idea of normalisation, we're comparing to 1. And this is something that we really do a lot in maths, but it sort of never gets mentioned anywhere else. But we can use this idea in different places, and it'll help us understand concepts far better as we go along. And in the future, I'll refer to the word normalisation, and I'll mean this comparison to 1. We've actually already had it, because we've had the 3 types of division, which are more than 1, equal to 1, less than 1. So those 3 types are just comparing to 1. So they are normalised measures. And there are quite a few normalised measures. Another one we've had is area. So that's how many metres squares. So first of all, a metre is a normalised measure because it means 1 metre. So when we say 5 metres, we mean 5 lots of 1 metre. A metre square is a normalised measure because it's 1 lot of 1 square. And then if we say sort of 12 metre squares, we mean 12 lots of 1. And so on. And we'll see many more as we go along. And percentages are the first example of that for us. So let's now look at how to find any percentage of any number. So by that I mean something like 41% of 32. Now you might have done this already, where you do say 10% and then 1% and then you find 40% and then you add that answer to 1%, and 3 hours later you've got your answer if it's correctly all done and all added together. So what I'm going to do is just show you how to do it in a few seconds. To do it, you must have watched my first few videos. Okay, if you just jump in straight in here, it won't make much sense. But if you know how to do the first few videos in this course, this will be very easy for you. First thing I'm going to do is just draw a rectangle and just talk about what 41% of 32 means. So what that means is essentially some fraction of 32. So if that's 32, oops, let's get the right pen. If that's 32 as a value, 41% of it means sort of some amount here, roughly. Some fraction of it. So the question is, how much is that? If it was £32, what would be 41% of it? If you had to pay, say, a tax on £32, what would 41% of it be? So here we go, how to do it. So instead of doing 10%, 1%, all that stuff, ignore all that and just do 41 times 32. And if we do that, we're going to have 1 times 2 is 2, 8 and 3 makes 11, 4 times 3 is 12, plus the 1 is 13. Now that's not the answer yet, because we've got to do something else. Now, if you recall from the decimals video, I said that an important thing to remember is what happens when you divide a number by 100. What happens to the decimal point? And I said it 3 times, so can you remember what it was? Well, it's when you divide by 100, when you divide a number by 100, the decimal point moves 2 to the left. And since we're trying to find a percentage here, which is out of 100, that's what we need to do. So we need to divide by 100, move the decimal point 2 to the left, and that gives 13.12. And that's it. That is 41% of 32. So very easy. No complicated 10%, 1%, all that kind of thing. So if I write another one, for example, 21% of 81, just times them together. So 21 times 81. 1 times 1 is 1, 2 and 8 makes 10, 2, 8 is 16, plus 1 is 17, divided by 100, 17.01, that's it. I could go on, so let's do one more. Random choice, 21% of 37, so do 21 times 37. 7, 14 and 3 makes 17, 2 3 is 6, plus 1 is 7, divided by 100, 7.77. So in this way we can find any percentage of any number. For example, you must know a lot already, because if you think about every answer really, just like this key change effect, the answer is always the same. Just in a specific case, we're dividing by 100. So if you think about the times tables that you might be aware of, then you already know the percentages of all those. For example, let's say you want to find 3% of 5. Just do 3 times 5. So 3 5s are 15. and divide by 100. So it's 0.15. 4% of 6, 4 times 6, 24, divide by 100, 0.24. 5% of 7, pause it this time, do it yourself. 5 7 is 35, divide by 100, 0.35. 6% of 8, 48, divide by 100. 7% of 9, 63, divide by 100. So you get the idea. You see how quick that all was. So there's loads that you already know that you can just try for yourself now and realise, hopefully, that, oh, yeah, actually, I know what 8% of 12 is, which is 8 12s, 96, divided by 100, 0.96. Because when you divide by 100, the decimal point, you're just going to move 2 to the left. And that's it. So now you can find any percentage of any number. Okay, so let's try a few for practice, and again, I'll start slow and then get faster. You might want to pause the video now and try these yourself. All it is just more practice of multiplying. Towards the end, we've got a few which are incorporating the previous lessons of using decimals, so watch out for those. But once we get to that, you'll see what to do. So let's begin. So 41% of 31, just times 41 by 31. So that's 41 times 31, which is 1, 7, 12, so it's 12.71. 11% of 11, 11 times 11, 1, 2, 1, 1.21. 71% of 42, 2, 14, 18, 7 4 is 28, 29.82. 41% of 21, times them together, 1, 6, 8, 8.61. So hopefully you can see, you get the idea. I'm actually trying to go slowly here, but they're quite easy to be honest. So 31% of 41. Now that's interesting because that's very similar to 41% of 21 of 31. And we'll see if we times them together that we'll get the same answer. 41 times 31 or 31 times 41, doesn't matter. So actually there's a bit of a benefit, which is that the answer to the two are the same. And that actually gives us a bit of help with doing more complicated percentages, which I'll come to a little bit later. 9% of 7, done that already, 9 7 is 63, so it's going to be 0.63. 91% of 41, time them together, 1, 9 and 4 is 13, 9 4 is 36, so it's 37, it's 37.31. 61% of 300. So here, this is where we start to use some of our previous lessons. We're going to put the numbers in a place that's convenient to us. So 61 times 3, ignore the zeros, so it's just going to be 3 times 1 is 3, 3 times 6 is 18, put 2 zeros in, divide by 100, 183. 72% of 32, times them together. 2 times 2 is 4, 14 and 6 make 20, 7 3 is 21, 23, divided by 100, 23.04. Okay, so let's get to these ones with decimals. 4.1% of 31, so again, we'll just multiply as normal. Now I've had this one already. So 1 times 1 is 1, 4 and 3 makes 7, 4 3 is 12, so we're just ignoring the decimal point for now. But we can't ignore it, now we've finished, so we put it in, so 1 decimal place in the question, so 1 in the answer, and then we need to divide that by 100, so we move it 2 to the left. So the answer will be 1.271. So that question probably seemed a little bit hard to look at first, but actually, just following the usual key change effect process is not so bad. And the same goes for the next one, 0.9% of 7. Well, we've had 9% of 7. So 0.9% of 7 will just be 9 sevens, which is 63. 0.9 will be 6.3 times 7 because of one decimal place. And divide by 100, it's going to go 2 to the left. So it's going to be 0.063. For 61% of 0.3, that's actually again the same one as this one. So the answer is the same. So we just do 3 times 61 as usual. So I'll just do it down here. So that's going to be 3 times 1 is 3, 3 sixes are 18. Then I need a decimal point. Then I need to divide by 100. So it's 0.183 or 0.183. And then finally, 4.1% of 2.1. So let me just get rid of everything because it's getting a bit messy here. 4.1% of 2.1. I'm just going to do 41 times 21, which we've already seen. So that's 168. 2 decimal places is 8.61. Divide that by 100. It's going to go 2 to the left, so it's going to become 0.0861. So decimal point went from there to there. So there are some examples far beyond actually what's required for, say, GCSE level, but they're very useful in everyday life because often we do need to calculate percentages, and if you can do it in a few seconds and without a calculator, then obviously you're going to be well ahead. So as usual, if you've got any questions or comments, please put below or get in touch, and I hope you enjoyed the video.